Welcome to tutorial 120, the GHS interface. Now we're going to focus on command formatting. In this tutorial, we're going to cover the GHS command format. We're going to introduce the concept of GHS Run Files and how you put comments in Run Files. Going to recap on the GHS Coordinate System, and more importantly, how that coordinate system then affects GHS Side designations. First, a quick disclaimer so that I don't end up with a lawsuit. This presentation is for instruction only. It's not to be used in engineering or construction. I am not a representative of Creative Systems. This presentation is not endorsed by Creative Systems, and I make no claims of accuracy to the latest version of the GHS software. If you're interested in the official training for GHS, contact Creative Systems. You can look up their website, www.ghsport.com, or contact them directly via phone or email. So let's get into the GHS command format. So GHS is primarily a command-driven language. There are quite a few menus available, and you can do quite a bit with menus, but if you really want to be a power GHS user, then you need to be able to work with it via command line. So the basic format of commands is you first have the command name, then any parts specified, then any values, and if you have more than one value, they'll be separated by commas, and then any parameters. Parameters are things that will modify the command. So don't worry too much about applications now, just focus on the formatting for the moment. So again, first part is always the command name, and GHS will let you abbreviate that command name down to just 2 letters. So sometimes if you're looking at other example files, you'll only see a 2-letter command. That's an abbreviation. And then you can see how parts will be specified within parentheses. We'll cover more about that later, about how you specify parts and what that means. Then the command may have one or more values. So if there are multiple values that it's specifying, for example, the weight, you have to specify weight and center of gravity. The values are separated by commas. GHS actually ignores spaces in the command line. It doesn't care how many spaces you put between values. Commas are what separate values. And then finally at the end you have what are called parameters. These are things that are specific to each command, and they modify the command's execution. And those are specified with / marks. And these slash marks are actually what separate them, but by convention most people will also separate them with spaces. So part specification. We'll talk more about this when we get into model building in GHS, but parts are essentially subsets of the ship model. You can think that ship model is built up of multiple parts, and you can select individual parts within the ship model. For example, a single fuel tank would be one part. And you can even specify multiple parts by not only specifying the name, but you can also specify by putting commas between part names. You can select multiple part names. Also, you can use the wildcard to match any patterns or any part names. So, for example, most people, when they're naming their fuel oil tanks, when they're creating the part names for fuel oil tanks, will start everything with the letters FO for their fuel oil tanks. So it'll be FO-8745, something like that. So if you wanted to say load up all of the fuel oil tanks on a ship, you could just specify FO star, and that's saying anything, any part name that begins with the letters FO. It doesn't work the other way around though. You can't do star FO. So it's always starting letters, and then the wildcard happens at the end of the part name specification. So here's an example of how that works. You can see here how I selected all of the fuel oil tanks on the ship. So the first command, read FV, that's just me reading in the geometry model. And then load FO star 1.0. Don't worry too much about the command, just look at what's happening in the parentheses. So FO star, you'll notice in the list of tanks that got changed, every single one of those tanks starts with the letters FO. And so that's how the wildcard works. Now I will point out, if I had tried it the other way around of star FO or star.c, for example, to load all of the tanks that are on the center line, that doesn't work. It doesn't work with the wildcard character at the beginning. Next, we need to cover file paths in GHS. So GHS interacts with a lot of files. It opens up geometry files, it saves report files. There's a lot of file reading and writing going on, and you have to be able to specify the paths of that. Here's the important thing to know. File paths in GHS were originally based on DOS formatting, and that meant that there was the DOS 12 character limit. Now, they've cleared out most of those limitations from GHS. Most of the parts of GHS will now let you write in file names that are pretty much as long as you want. But just watch out for that, because every now and then you'll find some obscure part of the program that still follows this DOS formatting convention and has the limit of 12 characters in the file path, or in the file name, excuse me. And that's why you see most GHS files are very brief in their names. Other things that you need to know is when you're typing in the path to the file, C:\/ my directory / my subdirectory / project name, whatever, you can't put spaces in the file path unless you put the file path within quotation marks. So, for example, here, if you look at the example below, change directory is expecting a path. And you'll notice how there is actually a space in my example here. C:\test path with space, but I've stuck it inside quotation marks. GHS will happily work with that. Okay, so let's have a bit of homework so you can practice these skills. Open up the run file in homework 221. What that run file will do is it's going to open up a geometry file and list out all of the part names within that geometry file. And what I want you to do with that is load the fuel oil tanks. So you're going to use the load command, then type in the part specification and 1.0. This is pretty much the same thing as the example that you saw me use earlier. So in this example, all the fuel oil tanks do start with FO. And then you want to check to see if it actually did change that. So type the command status. The status command will report the results to see whether or not the tanks were loaded up. And then what I want you to do is empty all the tanks. So that's load star. You can just use the wildcard on its own to select all tanks. And then 0. So that's saying give everything a load of 0. And then load up the WBT and the DB tanks to 100%. So 3 steps here. Load your fuel oil tanks, then unload everything, then load up the WBT and the DB tanks. And you'll have to use wildcards for all of that. Okay, let's move along. Now, I mentioned something in the back there called a run file. So GHS uses run files quite a bit, and this is where you're going to start to see the power of GHS. You can take all those series of commands that you might use for an analysis, write them down in a text file. You give it the .rf extension, and GHS can actually play all of those commands in sequence as a run file. That means you can start to automate a lot of processes. It is a plain text file, so you can open it up with your favorite text editor. And GHS does execute all the commands in sequence. So it will start at the top of the file and run all the way through whatever commands you give it to the bottom. To run a run file, first thing you do is start up GHS. You navigate to the directory that the run file is located in. and then you use the command file run, and then your file name. You can also type the command directly in, so just type run and then the file name itself. That will also work. Notice there is a space between run and file name. If you open up some of these run files, one of the things you might notice in there is that there are comments in the run files. Comments are really handy. They are just notes that the programmer wrote. It's not part of the executed code. It's just notes on the execution of it. So little comments in there that the programmer wrote to each other, memory joggers, explanations of what the code is doing, handy things like that. And they're marked with a reverse apostrophe. So any line that starts with a reverse apostrophe is a comment line. Now take a second to find the reversed apostrophe on your keyboard, because it's not the normal apostrophe. It's actually the reversed one. If you're using an American keyboard, it's normally going to be on the top left of your keyboard, normally around the just above the tab key. It'll also have a tilde on it usually, so look for that. And this is an example of how comments work. So you can see the top line. This is a comment. Notice that reversed apostrophe right at the beginning. The minute GHS sees that, everything else on that line is a comment and gets ignored. If you start a new line of comments, that line has to also start with a comment mark. So GHS doesn't continue lines. And if you look here, the second row of text here, this example. So we start with load star 1.0 a GHS command. So the GHS will execute the loading all of the tanks up to 100% because the comment starts after that command on the line. Whereas you can see here, I took the same command, but I stuck the apostrophe in front. And once the command is hidden behind that apostrophe, it becomes a comment and it has no meaning. So that's really handy for turning pieces of code on and off. Okay, next thing we are going to review is the GHS Coordinate System. Just going to quickly recap on this, and then I'm going to explain why. So the GHS Coordinate System is by default an American coordinate system. It starts with an origin at the bow, positive x-axis going aft, positive y to starboard, and positive z is going up. But a lot of people also like to use the European coordinate system, which starts at the stern, at the aft perpendicular, x goes forward, y goes to port, and z goes up. The good news is you don't necessarily have to worry about that in GHS. So in GHS, you can also specify the side. You can specify coordinates both as a direct number or as a letter, essentially. So rather than worrying about whether it's plus or minus for this thing, you can just say aft, forward, port, starboard. And when you do that, GHS will assume that you're using an American coordinate system. So when you say, I want something 4 meters starboard, GHS assumes starboard using this coordinate system here. So if your model is not defined using this coordinate system, then you're going to have trouble using the forward, aft, starboard, port deal. So just keep that in mind. So to recap, if you want to specify longitudinal coordinates, F equals forward. That's the negative x-axis. So -5 is the same as 5F. A is equal to aft, which is along the positive x-axis. So +5 is the same as 5A. Transverse coordinates, S is starboard for positive, and P is port for negative. So just remember that when you're typing port or forward, GHS isn't smart enough to find the pointy end of your ship and always go to the actual port side or the forward end. GHS just automatically converts that P over to a negative and the F over to a negative. And that's how those work. Here, let's give an example. Let's assume you wanted to specify a relative position, something that is 55 meters forward of the aft perpendicular, 6 meters starboard of centerline, and 10 meters above the baseline. Now, don't worry about origin location yet and where we are relative to that. I just want you to focus on the 55 forward, 6 starboard, 10 above. And what are all the different ways you could write that? Well, you could do negative 55, 6, 10. That's perfectly fine. You could do 55F, 6, 10. Notice there are commas between each one of these. Or you could do 55F, 6S, 10. So any of these combinations are allowed. You're perfectly allowed to mix and match using the side notation of just straight positive negatives. Things that you cannot do, you cannot do negative 55, 6, 10, because what GHS sees no commas, and how GHS interprets this is negative 55,610. You also can't do 55S 610 because S doesn't work for a longitudinal position. And you also can't do 55F 6S 10U. There is no U, there is no D, there's no up and down in the vertical axis. It's just straight position. Okay, well, thank you very much for watching this tutorial. I hope you enjoyed it. You can see more like this at dmsonline.us. Thank you very much. Thanks for watching. I hope you liked it. Hey, did you know that there is a magic button down below? Click the like button or even the subscribe button and I will make more videos for you.